Hello everyone and welcome back to our Lee County Library Science Club. It's great to have you with us again. Just want to remind you, please make sure you have your parents' permission and some supervision when you're doing these experiments with us. Today we are going to make something really fun. It is called Oobleck. What? That's right, Oobleck. Now the name of it actually comes from a Dr. Seuss book. He wrote a book several years ago called Bartholomew and the Oobleck. Now what we are making today is not exactly what they made in his story. Ours is just a little more manageable. But what Oobleck is a mixture made of cornstarch that creates what is called a non-Newtonian fluid. Now that name comes from Isaac Newton, who originally proposed a law regarding fluids that their viscosity would only change due to changes in temperature or pressure, not stress. So if we're talking about a non-Newtonian fluid, we're talking about something that does change its viscosity under stress. But let's start at the beginning. What is viscosity? In scientific terms, it is the resistance to deformation of a fluid. In simple terms, it is the thickness of a fluid. For instance, at home, you have lots of different liquids in your kitchen, right? You've got water and milk and vegetable oil. You probably have something like honey or some cream. Well, viscosity is the thickness. So if you took your honey out of the cabinet, it's much thicker than your water, right? It moves much more slowly. It resists a lot more if you push your finger into it. And when you try to pour it out, it'll drip in nice big long drips instead of a steady stream, right? So lots of different liquids and fluids have different viscosity. But what Isaac Newton said was that that thickness wouldn't change just because of something pushing on it or applying stress to the fluid. Now he was correct for a lot of fluids, but there also exists a lot that he was actually wrong about. So let's think for a second about water. If you have a glass of water like this, if I push on the water or I swirl the water around, the thickness of it doesn't change, does it? It's always just nice, thin, easily moving water. It will change viscosity if I make it really cold in here, right? If I get it to freeze, or if I get it close to freezing and some parts inside of it start to freeze, then it will get thicker and it will move much more slowly. But it takes that dramatic change in temperature to cause the change in viscosity. So a non-Newtonian fluid is one that will change viscosity due to the forces that are being acted upon it or when it is put under stress. An interesting thing about non-Newtonian fluids is there are actually different kinds. They don't all react the same way to stress. Some of them get more solid under stress. Some of them get more liquid under stress. And sometimes it's a difference between the amount of stress applied versus the time over which that stress is applied. So, there are actually 4 different types of non-Newtonian fluids. Now they all have some pretty big names, but I'm also going to give you an example of them that you can see right in your own kitchen. So don't get hung up on the fancy names, just try to remember the differences between how they react. So the first kind is what is known as thixotropic. Again, big word. What it means is that the fluid will become more liquid over time as you apply stress or force to it. So for instance, if you have a jar of honey and it sits in your cabinet for a long time under no stress, it actually starts to solidify, right? But if you can take a spoon or a knife and put it in that honey and start stirring, the longer you stir, or the longer stress is applied to the honey, it actually becomes more and more liquid. So if you've got some really hard, thick honey, just stir it for a long time, and it'll get nice and liquid and will flow much more easily. The second type is called rheopectic. Again, odd words, but it's basically the opposite of the thixotropic. It means that when stress is applied over time, that type of fluid will become more solid. So for example, if you have some heavy cream in your refrigerator, you can actually turn the heavy cream into butter by what's called whipping it, or just stirring really fast for a long time. It's not about how much pressure or how much stress you're applying to it, it's about the length of time that you are applying that stress. So the more you mix the cream, the more solid it becomes and eventually turns into butter. The third type of non-Newtonian fluid is what's known as a shear thinning fluid. Now this one is not about how long you apply stress to something. This one is about how much stress is applied to the fluid. And in this case, more stress actually makes the fluid become more liquid or have less viscosity. A great example of this is tomato sauce. If you have some tomato sauce in your cabinet, or especially some ketchup, when that sits stationary under no stress, it becomes pretty solid. Especially some ketchup in your refrigerator, right? But when you take that ketchup bottle and give it a good shake, or maybe whack the side of it, it suddenly starts to flow a lot more easily, doesn't it? And that is because it is a shear thinning fluid. Now the final kind of fluid is the opposite of that. It is shear thickening, or it's also known as a dilatant fluid. And this type of fluid becomes more solid under more pressure. Now again, this is not about how long you apply that stress to it. This is about how much stress, how much force you apply to it. And this last one, the shear thickening fluid, that is what we're going to make today. So the example we have is Oobleck, which normally is made from cornstarch mixed with water. You can actually mix it with vegetable oil as well, but we're going to stick with water for today. So when we make this Oobleck, you're going to see when it's just sitting in the bowl, it's very viscous and it moves very easily. But if you try to put some stress on it, press on it, or even try to form it into a ball, well, it becomes more solid the more you push on it. So what you're going to need for our experiment today is some cornstarch, some water or vegetable oil, a measuring cup, a nice bowl to mix it in, and a spoon to mix it with. Now when you're making your Oobleck, it's important to use your measuring cups to make sure you get your ratio correct. If you're using water, you want to make sure you use 2 parts cornstarch to 1 part water. If you're using vegetable oil, it's 1 part cornstarch to 1 part oil. So, in my case, I have half a cup of water. Now what that means is, that's my 1 part water is half a cup, right? So if I need to do 2 parts of cornstarch to that, then I'm going to take my half, multiply it by 2, which means I need 1 cup of cornstarch. So I have a half cup measure. I'm going to do 2 halves to make my 1 cup. Okay, there's 1 half. Now be prepared, this can get a little bit messy. So you don't want to have anything on your hands. You don't want to have too much on your workspace either. There's my other half. So there's 1 full cup of cornstarch in half a cup of water. Next, you're going to start mixing it up. Now when you do this, you can start with your spoon and kind of spread the cornstarch into the water. But as you try to mix, you'll notice it gets really thick, doesn't it? Even though there's still some liquid around the edges here. So use your spoon as much as you can, but if you need to, you can get your hands in there and stir it up nicely. So this whole process is going to be a little bit strange, but you'll know you're done when you can take your spoon and just lay it on top and it'll sink right in. Okay? Now the cool thing about that is, if I try to push my spoon in, I have to push really hard to get it to go in there. But if I just lay my spoon on there, it sinks right in, doesn't it? And that is the change in viscosity that we're talking about. So we've got it mixed up here, and you can see I can swirl it around in the bowl, right? And it all just moves around, doesn't it? And that is because it's not under a lot of stress. But if I take my spoon and I try to pull it and try to move the oobleck, suddenly it becomes solid, doesn't it? You can actually pull it out. It'll kind of come off in a chunk, but then it'll drip right down as a liquid. Very cool, isn't it? And so once again, Oobleck is what's known as a shear thickening non-Newtonian fluid. One of the other cool properties of Oobleck is actually the way that it reacts to electricity or some form of electric charge. So if I have a balloon and I go ahead and rub it, give it some static electricity, so you can see there's some static electricity, it'll stick to my hand. If I bring that close to the Oobleck in the bowl, well, nothing happens, right? And that's because the molecules can actually change how well they are packed together. That's what changes the viscosity. So when there's a lot of them packed together, the static from the balloon doesn't have an opportunity to pull anything towards it. But if I pick some up and let it run like a liquid, you can see now it gets affected and attracted to the balloon, doesn't it? And again, that's because of that change in viscosity. The thinner liquid, as it runs down, is able to be pulled by the static electricity more so than when it's all packed together down here in the bowl. Now I encourage you, if you have the time, to really play with the Oobleck, because if you get your hand in there, you can kind of grab it and form it into a ball in your hand, and then if you open it up and let it go, you see it just turns into a liquid and runs right down into the bowl, doesn't it? But it feels, when you grab it, it kind of feels like almost some Play-Doh or silly putty type thing. But again, once you stop applying that pressure, it just runs out in a liquid form. Now don't worry too much about making a big mess with the Oobleck, because all you have to do is add more water to it, and that stickiness and viscosity will actually go away, and it'll just eventually become like water as more and more gets dissolved into it. But remember, Oobleck is a wonderful example of a non-Newtonian fluid, or a fluid that will change its viscosity due to stress. Now this principle is not only important for food in our kitchens, even though that's pretty much all we've talked about so far. There actually is a lot of research being done into using this for safety, for protection, okay, for things like bulletproof vests, or even in your car in place of an airbag. Okay, if you can think about any instance where you might have a sudden strong force or stress put against an object, if you could have a non-Newtonian fluid there where it moves easily when it's not under that stress, but as soon as there's that sharp force, it'll harden into a solid, well, that could actually create some really interesting opportunities for safety equipment. Now, another really cool thing about non-Newtonian fluids is that despite everything we know, scientists are still not entirely sure why they behave this way. Okay, they talk about there being interesting interactions with the molecular forces, and we do know that in something like Oobleck, the molecules themselves actually compact closer together when they're put under stress, creating that new solid where it was liquid. But they still are not entirely sure why. So there's a lot of research being done into that, and hopefully it can lead to some really cool discoveries. Please have lots of fun with your Oobleck. It's a really interesting substance, and I hope you enjoy it. Thanks so much for watching. We'll see you next time. Bye!